Welcome to a podcast on the introduction to using matrices to solve systems of equations. Matrices are incredibly useful in many different areas. For now, we will use them for their initial purpose, solving systems. Given the following system, we will first learn how to write the associated augmented matrix. To start, you will write down all the coefficients and the answer values, including all the minus or negative signs. If there is no coefficient in the front of the variable, use the understood coefficient 1. So looking at the matrix, reading down each column, you will see that 2, -1, and 1 correspond to all the x coefficients. 3, -1, and 1 correspond to all the y coefficients. -1, -1, and 6 correspond to all the z coefficients. And finally, 6, 9, and 0 correspond to the answer values. Now let's look at another example. In sample problem 2, the equations are not set up like the first problem. Instead, the variables are in different orders. For example, the first equation is ordered y, x, z, while in the second equation, they are ordered x, z, y. So it is best practice to reorder all the equations so that each variable aligns with each other. When reordering, make sure to include all the signs, either positive or negative. Now that you can see that all the x's are aligned, all the y's are aligned, all the z's aligned, and all the answers or constants are aligned. In the last equation, we had to move the -2 to the other side by adding +2 to both sides. Additionally, it is important to note that the third equation does not include a z value, but that is okay. Now that we have the reordered equations, we can turn the system into an augmented matrix. As like before, we will list only the coefficients and the corresponding positive or negative signs. So you can see we have -2, 3, 1 that corresponds to all the x's, 1, -2, 1 that corresponds to all the y's, -1, 1, and now 0 that corresponds to all the z's. There is a 0 there because there's no z in the third equation. And then finally, for all the answers, we have 4, 2, and 2. Another important aspect of matrices is their size. The size of a matrix is given in the form of a dimension, much as a room might be referred to as a 10 by 12 room. The dimensions for a matrix are the rows followed by the columns. For example, the matrix below has 3 rows and 4 columns, making it a 3 by 4. The rows go across while the columns go down. If a matrix has the same number of rows and columns, it is referred to as a square matrix. In this example, you would refer to the size as a 3 by 3 square matrix. Now that you had an introduction to matrices, we can begin discussing how to solve systems of equations using the matrices on our calculator. So let's begin with the following system. Primarily, we must make sure that all the variables are aligned. And in this example, they are. So now we can set up our augmented matrix. So, reading down, we should have 2, 3, -2 for all the x's, 6, 10, -6 for all the y's, -4, -7, 5 for all the z's, and 8, 12, and -3 for the answers. So before we can pick up our calculator, we must first determine the size of the matrix. Remember, the dimension should be rows by columns. So our matrix is a 3 by 4. Now it is time to take out your calculator. To solve using our calculator, we must bring up the matrix menu. To do this, we will press second and then the x to the -1 power, which is in the top left under Math. Then we will scroll to Edit. So the first thing we need to do is put in the size of our matrix. So we had a 3 by 4 matrix. Then we can start putting in the variables in our augmented matrix. So reading across, it should be 2, 6, -4, 8. Then 3, 10, -7, 12, -2, -6, 5, and -3. Now we can quit since we set up our matrix. So we'll do second quit. And we're back to our home screen. So from here, we must tell the calculator what to do with the matrix. So we will begin by going back to the matrix menu. So second matrix, and scrolling to math now. You're going to scroll all the way down until you see RREF, which is under B. So RREF. RREF stands for row reduced echelon form. But don't worry, you don't need to memorize that. You just need to know which stroke to use on the calculator. So you're going to select RREF, then go back to our matrix menu again, and we're going to call upon matrix A since that's where we put our information. So we will do row reduced echelon form matrix A, and we will press enter. So basically, this is telling us that 1x equals -1, 1y equals 5, and 1z equals 5. So if you put it back into equation form, you would see that 1x equals -1, 1y equals 5, and 1z equals 5, which means the solution is x equals -1, y equals 5, and z equals 5. Thank you for listening to this podcast. I hope you learned how to use your calculator in matrices to solve systems of equations.